Hello everyone. Today we are going to learn about fuzzy logic, truth values and tables in fuzzy logic, fuzzy propositions, fuzzy rules and its decomposition and aggregations. Okay. Let's before jumping into the topic, let's know what is proposition. Proposition. Proposition means it is a statement which has a true or false values, right? True or false values are truth values which are given to a particular statement. If the generalized form of a statement is x is a, let x be the okay, let's jump into the example and I'll explain. Yes, here is the example. London is in UK. London is a subject and UK is a predicate. UK gives the geographical location of London. Okay, that means predicate gives the property of a London. Yes, UK gives geographical property of a London. Okay, and it has a truth values like a true or false. And coming to the truth tables, yes, here we have conjunction. Conjunction means we use and operator. Truth table means, a truth table means it defines logic function of two propositions, right? It defines a logic function of a two proposition. Disjunction, implication, bidirection. Like x and y, it comes under a conjunction. X or y comes under disjunction. If x, then y, then implication. If and only if we use if and only if for two propositions, like x, if and only if y, that is bidirection. Okay. And then coming to the truth values. Truth values range from 0 to 1. Let's take example of Satish is a student. Here we have Satish is a subject, student is a predicate, right? And it has a truth value of 0.8. It is between 0 and 1, including 0 and 1. Okay. And next are operations. In operations we have we can perform if we have truth values of two propositions. We can have more simplification with a minimum of t of x comma t of y with a conjunction. Okay, we have to learn in a sequence, right? If we got and, we should do conjunction and it has minimum. Okay, learn in this sequence. If we got r, disjunction, then max. And if we got implication, not function, it is 1 minus the truth value. And here is a simplification of implication. Okay, and next this is another this is fuzzy proposition. I said you right. What is proposition? Proposition which has this which is a statement which has true or false values, right? Let's see, Sham is a student. It can be having a truth value of 0, or it may be having a truth value of 0.2, it may be having a truth value of 0.8, or it may be having a truth value of 1. It can be changed. And also another statement, another proposition has given, Sham is a failure. T of Q is equal to truth value is given 0.6, and Sham is not failure, right? Okay, Sham is not failure means we are doing the complement of a proposition, and Sham is a student and a failure. Here we can see and operator. If we have and here, and means we have to do conjunction then minimum, right? We have done the simplification same. We took the truth value of first statement as a 0.8 and truth value of second statement as 0.6. We got a minimum of that 0.6. Yeah, now let's see fuzzy predicates. Satish is tall. I have explained through it through the examples. Yeah, Satish is tall. Here, tall is a tall, short, quick. These are the fuzzy predicates, which gives ambiguous meaning, right? It is not particularly saying that Satish is 5 inch, 5 feet, right? 5 inch means this much, 5 feet. And fuzzy predicate modifier, very fairly. This gives like for example, the climate is moderately shiny, right? Moderately means it is not saying about the temperature, right? And fuzzy quantifier is most, several, many. Like if you are given some elements, right? In this some elements, some of them are greater than 10. Some elements are greater than that. This is a proposition. It is not, he is not mentioning the number of elements which are greater than that, right? It is not giving the full meaning. And fuzzy qualifiers. Fuzzy qualifiers here degree of based on truth x is t. Degree of the truthness of a given fuzzy proposition. Okay. And based on probability. Here lambda is a probability. Here in the previous statement t is true. And based on possibility, x is pi. Pi is here possibility. And coming to the crisp proposition. It has a thin line difference between the fuzzy proposition and a crisp proposition. In fuzzy proposition, fuzzy set membership range from 0 to 1. But in the crisp proposition, we have only 0 or only 1. Okay. And next is fuzzy rules. These are also known as fuzzy implication, fuzzy if-then rule, fuzzy conditional statements. Okay. Here you can see if x is a, then y is b. Okay. X is a is antecedent or premise, and y is b is consequence or conclusion. These are the if antecedent, then consequence. If premise, then conclusion, like that. And the fuzzy rule R is denoted by A implication B. Here implication is if A is proposition and implication, then B is another proposition. Okay, here B is conclusion, A is premise. Okay, next it is explained through example. Here let's see the statement first. Yeah, here is the statement. If temp is high, then pressure is low. Okay, here temp is one of the set and pressure is one of the set. Temp has some values, 25.1 and 30.2, 35.5, 40.6, and pressure is pressure having the 2, 0.3, and these are all forming in a matrix is represented by what we call fuzzy rules. Yeah, and decomposition of rules. These are 4 types. Let's see the first 2 types. Multiple conjunctive antecedent. If x is a1, a2, an, these are the some sort of elements which comes under the first premise. Then y is bm. Okay, bm is the second premise. See, second conclusion, right? And the conjunctive word comes, what I said, the sequence to be remembered, and intersection, minimum, and one thing. Yeah, that's it. And intersection, minimum. These are to be remembered. Okay. And Yeah, now multiple distinctive antecedents. Here the same thing, but here we got disjunctive, right? Disjunctive means what is the sequence? You will get or and union and max. Yeah, these three things to be remembered, and this is the sequence for disjunctive, and the sequence for conjunctive is and intersection minimum. Okay. And these are the simplification formulas for the multiple disjunctive as antecedents, and multiple conjunctive antecedents. Yeah, and these are the other two rules. Not rules. Decomposition method. Conditional statements. Conditional statements can be break. Here is an example. If A1 then B1 else B2. You know this conditional statement, right? If the true value will be printed, else the false value will be printed. Okay? If the condition is true, then then B1 will be printed. If the condition is false, then B2 will be printed. Okay? And here is the decomposition. If A1 then B1, or if not A1 then B2. Yeah. And nested if then rules. This is easy, right? If A1, then if the then after we get a conclusion, right? In conclusion we have another two, what we call premise and conclusion. Yeah. If A1 then if A2 then B1. Yeah. This can be decomposed into using AND. If A1 and A2 then B1. If the both conditions are true, then only B1 will be done, right? Because so that we have used AND. And coming to the aggregation of fuzzy rules. These are the two aggregations which comes under the fuzzy aggregation of fuzzy rules. Yeah, conjunctive system of rules. In this conjunctive system of rules, we got conjunction, right? Remember the sequence. What is that? And intersection minimum. These three should be remembered. Again I am repeating, and intersection minimum. Okay. In this conjunctive system of rules, it should satisfy all the rules. Yeah, all the rules means like if we come into the AND, right? If all are true, then only true, right? If all are true, then only true. That is why this aggregation is done, and using and user intersection. This is for multiple one, the simplification and distinctive system. Yeah, distinctive system of rules. The satisfaction of at least one rule. Yeah, distinctive. Remember the sequence. Or union maximum, right? Or union maximum. It in false, what are the statements? If any one of it is true, at least one is true, then it is true. If all are false, then it is false. Yeah. It is done by union, and we should find the maximum. Okay. Yeah. Thank you.